You have a Git repository on your computer somewhere. It's this orange repository here. And you also want the same repository somewhere else, probably on a different machine. Here, I made it purple. Now, the machine that hosts the purple repository must be able to connect to the machine that hosts the orange repository. So you might have some technical setup to do here. You have to run a git daemon process on the orange repo so that the purple repo can connect to it, and so on and so forth. But in this training we don't care about these technical details, so let's make it easier. I just moved the whole cookbook project to GitHub and removed it from my computer. So now the orange repo is in the cloud, right? A service hosted on the GitHub servers. And the purple repo will be on my own computer. So I want to get a copy of the project on this computer inside this empty directory. You probably know which command to use here. It's the git clone command. It takes the address of a Git repository, which I can copy-paste from GitHub. There, and now I have the project. All the files are here. But I didn't just get the files. I got the entire .git directory as well and all the files it contains. Here is what git clone did. It created an empty directory for the cookbook and it copied the .git directory from the GitHub project to this directory. I'm simplifying here, it didn't literally copy each and every file. For example, unless you're using a very old version of Git, git clone only copies one branch, the main branch. If I want to work with the other branches on the remote repo, I need to give specific commands to do so. But that's a detail, an optimization if you wish. The important part is, Git did copy over the objects in the object database. They are in here. After copying this stuff, Git checked out the main branch to rebuild these files in the working area. Remember, the working area in Git is not very important. You can always rebuild it on the fly from the content of the .git directory. And since the .git directory contains the entire repository, now we have a copy of the project and its history on this computer. This is an important point, so it's worth repeating it. Now that we have two clones of the repo, one on GitHub and one on this computer, both clones are equally good. Git is not like Subversion or other traditional revision control systems that need a centralized server and everyone else is just talking to that one server. Instead, both computers now contain the whole project and its history. We could have as many of these clones as we want synchronizing with each other. Of course, you can still decide that one clone is the most important one. For example, if you have multiple developers working on the same software project, then you will probably decide that the repo on GitHub is the reference repo, the one that you build the releases from, and everybody must synchronize with that one. That's why I drew the GitHub repo on top. You can still synchronize the developers' repos directly with each other, but even then you probably want to appoint a well-known reference copy that is visible to everybody and everybody synchronizes with it. However, in Git that's not really a technical issue, it's more of a social issue. It's a convention. From a technical standpoint, all of these clones are peers.